philosophy or a way of life rather than a religion in the traditional sense, especially since it doesn't center around a creator god. The same goes for Jainism in many ways. So it's fair to say that they have a unique place compared to more theistic religions. It's always interesting to explore those nuances and distinctions.
All right, very interesting, ChatGPT. This is going great. Okay, so what what is time?
Another big question. Time is one of those fundamental aspects of our reality that scientists and philosophers are still trying to fully understand. In physics, it's often considered as a dimension, much like space, and it's how we measure change and sequence events. But the true nature of time, whether it's something that flows or something that's more of a block that we move through, is still a topic of much debate. It's definitely one of those concepts that can really make the head spin.
Well, what do we know for sure, right? Let's backtrack a little bit. We know a few things for sure. We do know that time and space are one. Einstein said that. So if you can distort time, you can. I mean, sorry. If you can distort space, you can distort time. That's why near black holes, times just stop because the gravity and intensity is so strong. Like it's just it just stops. Basically, stop. I mean, if you watch, guys, another thing, if you watched Interstellar, you know what I'm talking about. Like depending on the gravitational pull of like, that's another very interesting topic, right? If you guys watch Interstellar, apparently there was a physicist on set helping Christopher Nolan. Dude, I mean, not on set. I don't know. There we go. We had ChatGPT here. Like, is that accurate? Did they have a physicist on like on set? I don't think it was on set. I think they helped them craft the script. Like, look it up on the internet and tell us.
Yes, you're correct. Kip Thorne, who is a renowned theoretical physicist, actually worked on the film Interstellar as a scientific consultant. He helped make sure that the portrayal of black holes, time dilation, and other astrophysical phenomena was as accurate as possible. So it was definitely a collaborative effort to bring real science into the storytelling of the movie.
All right, so let's go back to the original question. What is time? We do know. Let's cover the basics first. We do know that time and space are basically so. Are they? That's another question. Are they just linked, or they are the same?
That's a great question. In Einstein's theory of relativity, time and space are woven together into what's called space time. They're not exactly the same, but they're deeply interconnected. So if you affect one, you also affect the other. This is why massive objects like black holes can warp both space and time. So they're not identical, but they are part of one unified fabric of the universe.
And why is that? Why they are linked together?
The connection between space and time really comes from how we observe the universe. Einstein's theory showed that the speed of light is constant for everyone, no matter how they're moving. Because of that, space and time have to adjust to keep that speed constant, which means that distances and time intervals can stretch or shrink depending on how fast you're moving or how much gravity there is. So they're linked because together they help us understand how the universe works at a fundamental level.
I'm not sure if you answered my question. You so at the end you said they are linked because they help us understand how the universe works. I don't think they're linked because they help us. I think why the universe would link them to help us understand it. I don't think you answered my question.
I see what you mean. You're right. It's not that they're linked just to help us understand, but rather that the fabric of the universe itself links them. Essentially, the universe is structured in such a way that space and time are interwoven. This means that changes in one affect the other, and that relationship is fundamental to how the universe operates. So it's really about the nature of reality itself.
All right, so we do. So that's why some physicists theorize that we can indeed create wormholes, right? Because at the same time that they are deeply connected and linked, We know that we cannot change time, but we know that we can change space. Therefore, also manipulating time. Am I right?
Yes, that's exactly the idea behind concepts like wormholes. Since space and time are interconnected, if we could find a way to manipulate space on a large scale, like creating a shortcut through space with a wormhole, we could, in theory, also influence the passage of time. It's a fascinating concept that really stretches our understanding of physics in the universe.
How much, we're in 2025, right? How much power, technological power, do we as a humanity have to bend space, therefore bend time? I once heard that the Hydrogen Collider was capable of doing that in a smaller scale. Did I hear that correctly? Does that sound true to you? Oh, just researching.
You're right that the Large Hadron Collider can create extremely high energy collisions, and in theory, these collisions can produce tiny distortions in space time. However, these effects are incredibly small and not something that we can currently harness to actually bend space or time in any practical way. We're still quite a long way from being able to do that on any meaningful scale.
Okay, but it does. It does it. It just do it at a very small scale.
Yes, on a very, very tiny scale, it does.
So what is this tiny scale? Let's say that
Exactly. It's a super tiny effect, and it's not something that we can really measure or use in any practical way.
why you say we cannot measure it? It's like how tiny
The
it
scale
is.
of these effects is incredibly small, like subatomic levels. So it's not something that we would notice in our